domain. I think this is is this one yellow? Okay. Domain, range, function. I love this problem for multiple reasons. Each one of them has their own personality. And I love this one when I've got to figure out first if it's a function. Now, if I do some ordered pairs, let's go over here and do some ordered pairs. I actually did some of them on the board, except people were giving me the wrong numbers. So we'll try and do a little bit better. What is the y when x is 4? Go to x is 4 and tell me what the y is. 3. Okay. What is the y when x is 2? What is the y when x is 10? 3. Okay, we're good. Now, y's can repeat, so we're doing good. What is the y when x is -1? Oh, I see a 3, but I also see it paired with 1. Now, that's a red flag to me, because is that a function? Why? Because the -1s repeat, and that would be a specific if it says, why is this not a function? Now, it is important for you to recognize both of those were solid dots. If one of them was open, it would be a function, because it would have just been -1 if that one was solid 3, if that one was solid 1, but it wouldn't be both of them. So it's a great picture, but it's going to make I think the domain is going to be pretty easy. The range is going to look a little odd, but I think this is going to help you. So let's do a couple more. What's -3 going to be? 1. And what's -20 going to be? 1. Now, if you had this lesson in lesson 2, what's the range? If you think about lesson 2, you've already done lesson 2. What's the range? The set of 3 and comma or 3 and 1, right? That's it. So if you want to put that there, but we'll address it in terms of the graph here in just a second. So let's do the domain in red. So I'm going to come down here. Now I'm looking at the graph from left to right. So I want to know what's going on over here. And I know this x has a y, and I know all those to the left of it. So I'm going to put an arrow. Now, you okay? Now, when I come across, was there a gap here? Now, it's not a connected graph, but notice that does 1 have a y? It actually has 2 of them, -1. It has 2 of them. So, I mean, it's going to have an ordered pair in your problem. So, we're okay there. And then it goes all over here, and then it's going to arrow that way. And every one of those x's has at least 1 y. One of them has 2, which made it not a function. What's the domain? What is that? What do we say when it's every number on the number line? All real numbers. That tells you that you name the number, you pick a number, it's going to have a y. Guaranteed. Every number you name, if I say -1.93, it's got a y. In this case, it's an easy one because it's going to be 1. -17.2, 1. +4.7, 3. You know, we know that. I love that one because it's an easy one to know what the x's and y's are. So what is the range? What did we just say? It's either 1 or 3. Now, let's look at it graphically. When you look at it, now, a lot of people want to see, slide it over a little bit. A lot of people want to look at those arrows, but those arrows don't affect this. I'm looking at it. And I see a solid dot at 1, so I bring that down. And I see a solid dot at 3, and I bring that down. Now, the most common mistake is people want to shade between it. But are any of your y's going to be like 2? Did you have any x that had a y of 2? No. It was 1 and 3. And there it is. You can see it. Y equals 1 or y equals 3. And that's our set. Let's do the last 2. That should give you some time. I hated that the morning class didn't get much time. Did we already stick these in here? Okay, the next one I bet is this one. Yeah, it's the kind of curly Q thing. I don't know what else to call it. Now, I did go up there to do the vertical line test. Ooh, what do you mean it moved? I did go up there to do the vertical line test. I'm going to try to do it here, and if I need to go up there, I can. But we can do it by T-table, too, if we want to use our T-table values. Let me get a pencil. Okay, domain, range, and function. Now, I had students last year and over the years that can look at these visually. The way I do it, I can look at it and tell you the domain without doing the shading. But if you can't do it or can't do it right, use that shading. To me, that is the best way to get a visual. And then do what I'm doing here, setting you up some little numbers. Now, as I do ordered pairs, I'm especially interested. Now, I know -2 is not in my domain because it doesn't have a Y. None of these numbers over here, anything from, is -3 going to be in my domain? Does it have a Y? No, if it was solid dot, it would be yes. So -3 is not even in it. So let's see what's going on in here. I'm especially interested at -4 because that's going to help me know if it's a function or not. Does -4 have more than one Y? It does, doesn't it? One of them looks like it's about -1.5. And one of them looks like it's -5. Now, you only need, so it's not a function. And that's my example of why it's not a function. But there's several of them. I mean, if I pick -3.9, you'll see it has a point and another point down here. So all these kind of numbers right in this vicinity, right around -4, are going to repeat Y's. Or excuse me, repeat my X's. They're going to have X's with more than one Y. So that makes it not a function. That's a great example of it right there. Let's do domain. Now let's see what's going on from left to right. Do you see any arrows? Do we have any arrows here? No. So we know it looks like that -4 doesn't have a Y, but nothing to the left of it. So I'm going to bring down that open dot. And all these numbers in between, some of them have 1, some of them have 2, but every number between these two have a Y. But I get over here, and I know -3, something's going on right there, but I see everything to the right of that. All these do not have Y's. So again, that's an open dot. Now, does everything in between have a Y? Yes. Now, what is that inequality? It's a domain, just like we had over on page 10. We actually did one very similar to that. What is your X's between? Okay, is it 5 or 4? Oh, it is a 5, isn't it? Okay. I can't see the number, but I can see -4 and then negative. It looks like a -6 there. -5 and negative. I think it's -3, isn't it? Isn't that -3? Is that what you said? Isn't that -3?
That's -3.
Yes. You're frowning at me. Okay, let's look at our list. Okay, does -2 have a Y? I go to -2 is X. Does it have a Y? It does not. Does -2.5 have one? No. The first one is -3, but it really doesn't have a Y, but it's your beginning place, right? Because -3.1 would, -3.2 would, -3.3 would. All of those points to the left of -3 will have a Y. So all the numbers, infinite numbers, between -3 and -5, but not equal to them, have a Y. Okay, beginning to kind of get a little bit, I feel better with y'all. I don't know why, but I feel a little better with y'all than I did this morning's class. I don't know. I don't know why. Maybe it's just because there was a few more of them, but they weren't answering my questions always right, and that scared me a little bit. You know, I'd say, is that an open dot? And they'd go, no. And I'm like, okay, I'm not sure what you're saying. Maybe they hadn't done lesson 2. I don't know. Now we're interested in what's going from here to over here. I do not see any arrows, so there's going to be some kind of dots going on down here. Now I'm interested of everything between this number, which is a solid dot. So that means there are some X's that have 5 as the y. There's one of them, whatever that is. I think it's -4, isn't it? Does -4 go down to negative? Is that a 5? 3, 4, 5? Yeah, -4 goes down to -5. There's no holes in here. There's no gaps. So everything, all of these y's have points on that graph. So that means it has an x. But when I get up here, now you have to be careful when you have 2 dots. You have to watch, because if one of these was solid, one of them were open, we would still have to decide, is there an x that's associated with that y? Well, in this case, it's real obvious. There is no x that has 2 here, and there is no x that has 2 here. So that's going to be your open dot right here. Oh, a little bit to this. Do it that way. Oh, tell you what, let me just scribble and do again. Solid dot here, open dot here. Now, I'm going to tell you what I told second and fourth yesterday. This is not the lesson to make you run. I may have told you the other day, to run to the office and say, I don't want to be in this class anymore. It's too hard. This is a lesson that I had people last year that never got. You'll survive. You'll make it through. You'll be fine. This just gives you a taste of that level of Algebra 2 honors. It's just different. Geometry honors and regular geometry weren't that much different. We did probably some harder algebra problems, but it can get a little crazier in here. The ACT, if any of you have taken it, is definitely thinking outside the box. They don't just ask you, factor this, solve this. You have to do more STEM stuff now than it used to be. So what is that? It's a between, isn't it? And it's your y's. And what are they between? -5 was the lower one. And what was the upper one? 2. Either one of them equal? The -5. So y, I should have an x that has -5 as a y, and I do. It's -4. And then there are y x's that have all of those numbers used in their answer. Any of those numbers used in their answer. Now, let me see if there's anything else I need to tell you. I'm going to go ahead and